sorry, I forgot to record. Those are the first two answers. Good luck. Problem number 3.
Okay, I have a question
Yes.
before we even start number 3. Okay, I thought it would be no solution because I didn't think it had to be between -1 and 1.
Sine and cosine have to fall between -1 and 1. If you think about when we graph them and their domains and ranges, sine and cosine are always between -1 and 1. Tangent and cotangent can be anything. Secant and cosecant are the reciprocal of sine and cosine, so they're the opposite. They are everything bigger than 1 or smaller than -1.
Okay.
Okay, so as soon as I see that arc, that tells me inverse, which means I can only have one answer. Secant inverse can be in 1 or 2, but it's a negative, so that tells me quadrant 2. Okay, we don't even know when secant is -1.5, so we are going to have to use the calculator. We know that secant is the reciprocal of cosine, so that means cosine inverse is 1 over that. Now remember, I've told you don't put the negative in your calculator because sometimes it gives you the right answer and sometimes it gives you the wrong answer. So to be safe, we just never put the negative in. If we are in radians, so put it in radian mode, and then you are doing secant cosine 1 over +1.5. Now if you tried to put one in that wasn't possible, it will tell you domain error. It won't give you an answer. So when in doubt, you can always check it like that. I get a reference angle of 0.8411. We need to be in quadrant 2. So in quadrant 2, we're in radians, so pi minus that. And that gives us 2.3005. So the inverse is, if the original problem has an inverse, you get one answer. So you need to go back, make sure you know the quadrants for each.
Now, if this problem started out as just like secant of -1.5, would you find when secant is negative and then get the two answers like that?
Yes. So if I had instead said this, then you would tell me every time secant is negative, which is 2 and 3. So you will get two answers. This is one of them, but you would have a second. So that's the difference. Because this original problem does not have an inverse, you give me both answers. If the original has the inverse, there's only one. Any other questions there? Yes.
So the bottom one right there,
Mhm.
is that the one you plug into your calculator to get right?
You would do the same thing. So if you, this means that cosine is 1 over that. If you want to move that cosine to the other side, it becomes an inverse. But the original problem didn't have an inverse, so we still have both answers. So then you would do the cosine inverse of the positive and you get this reference angle, and then put it in both quadrants. Other questions? So problem 4. All right. When you have a function and an inverse, then with this you could put it in your calculator, but it's going to give you a decimal answer, and I told you I wanted exact answers when we did this. The answer to an inverse is always an angle. It's saying cosine of some angle is 3/4. And then you have to find what tangent of that angle is equal to. So without using a calculator, I do not know the angle that makes cosine equal to 3/4. But we could draw a picture. Cosine inverse could be quadrant 1 or 4, but it's positive, so that's quadrant 1. Cosine is adjacent over hypotenuse, so you could do Pythagorean theorem. whether you pick the positive or the negative. Yeah, if you're going to go up, that's a positive. So now, this is where my angle's at. Sorry. Thank you. So tangent is opposite over adjacent. So that's radical 7 over 3.
So you knew that it was in the first quadrant because it's all of it is positive,
Mhm.
not like half of it.
Alright. Problem number 5. This is very similar, but I switched it. The last one, the inverse was the inside. This time I had the trig function on the inside. It's kind of a trick question because if I say tangent of pi over 4, don't we know that? It's just the tangent of 45, which is 1. So sine inverse of 1. This is a unit circle question. If you need it, I will give you a blank unit circle on the test, but you can't have a filled out one, you know, so you have to be able to fill it out if that will help you. On the unit circle, sine is your y, so when is y equal to 1?
90.
At 90. So you could say 90 degrees, or you could say pi over 2. Either of those is fine. Number 6. Alright, this is one that you might be able to evaluate quickly if you recognize that you know when cosecant is negative 2. Did anybody catch that?
Hunter did.
Good job. That represents an angle, so you could evaluate, find your angle, and then do sine of that. Or it sounds like most of you did it like you did problem number 4, where you set up a triangle. So either way is fine. This means that cosecant of theta is a negative 2. So cosecant inverse could be in quadrant 1 or 4, but this was negative, so it's quadrant 4. Okay, this is like negative 2 over 1. Cosecant is hypotenuse over opposite. The hypotenuse has to be a positive. So this is my negative 1. So will this side be positive or negative? Positive, because you went to the right.
Sorry. Do you need to remember, so you have to remember those quadrants for this too?
Yes.
Okay.
Anything that has a negative, that inverse to begin with, you need the quadrants. So you could do your a squared plus b squared equals c squared. So your missing side is radical 3, but it turns out we don't even need it, because then I asked for sine of theta, and sine is opposite over hypotenuse, so that's negative 1/2.
Congrats, you did all the work for
Yes.
Nancy, you could have gotten that beginning.
Yes.
Oh, wow.
We literally wrote sine above it.
Huh?
We literally
Yeah.
above it.
We
literally wrote sine equals negative 1/2.
Yeah,
We did
if
the
you
triangle.
recognize, this just means sine inverse is negative 1/2. Anytime you have a function and an inverse, they cancel each other. So you could have got it right there too. But, hey, we still got the right answer. We just worked harder. You guys just wanted to show off all of your math abilities, that's what it was. Okay, so this one, is there any shortcut? No, because we don't know when tangent is negative 1/5. So that is an angle, we have to find cosine of that angle. So this means tangent theta is negative 1/5. Alright, tangent inverse could have been in 1 or 4. It was a negative, so it's quadrant. Tangent is opposite over adjacent, so because this side went down, that gets your negative. So a squared plus b squared equals c squared. Hypotenuse is always positive, so that is radical 26. So now I need cosine, adjacent over hypotenuse. which gives you 5 radical 26 over 26. Alright, so first page is all the section 6.1 stuff. Any questions about that? Okay, the rest of it is the equations. So number 8. Can I just divide by cosine theta? No, never divide by a trig function. Instead, we will subtract it over. So then you can pull out a cosine theta. Set each to 0. So we get cosine theta equals 0. So cosine, if you think about your unit circle, is the x. When does x equal 0? So we got those two answers from there. This says cosine squared equals 1. So square root plus and minus. That means cosine could be a positive or a negative 1. When is cosine positive 1? 0 degrees. When is it negative 1? 180 degrees. Those come from there. And because my angle was just a theta, not a 2 theta, we're done. I didn't on any of these, but if I'd said all possible solutions, what would you do? Every single one would get a plus 360k.
For that problem, because 0 and 360 are the same, so will either one of those work, or would you rather have the 0?
I would rather have the 0, only because if you look at the directions, it says between 0 and 360, and the 0 has a bracket and the 360 has a parenthesis. So only because of my directions, otherwise I wouldn't care. Other questions? Alright. Problem number 9. What do we do here? Yep. It's a quadratic. Do double check, make sure your angles match. Sometimes one of them is theta and one's 2 theta, so we have to use a formula. If the angles are the same, my trig functions are the same, we can just factor. Sine squared theta breaks into sine theta and sine theta. Multiply negative 3 and add to negative 2. What would that be? So set each one to 0. So you get sine theta equals 3. Is that possible? No. If you tried it, if you went to your calculator and typed in sine inverse of 3, what does it tell you? Domain error. So if you don't catch it, your calculator will. This one, sine theta plus 1 equals 0, so that means sine is negative 1. So theta, think about your unit circle. Sine is your y. When is y negative 1? And if I'd said all possible solutions, you do the plus 360k, but I didn't. So that's it. So this one is very similar to problem number 8. Can you just divide the sign and cancel it out? No. So what do we do? Okay, all my angles are 3 theta, so that's good news. I have 2 terms.
Take the sine 3 theta out and just
each of those to 0. Okay. First of all, both of these are 3 theta. What does that tell me?
Triple solution.
Good. Probably one of the biggest mistakes I saw in the homework is when people wrote down these angles, they just put theta equals. You have to use your angle. So this was a 3 theta. So when I get these numbers, this is 3 theta equals. So sine is the y on the unit circle. When is that 0? 0 degrees. And so this gave me both of those answers. This says cosine 3 theta is equal to positive 1. When is cosine 1? Right, 0 degrees, because cosine is the x. X is 1 at 0 degrees. Since I already have it, I don't have to list it again. So I have 2 answers. If I want to triple that, 2 times 3 tells me there should be 6. How do I get the others? So 0 plus 360 is 360. Add 360 again, you get 720. 180 plus 360, 540 plus 360 is 900. But I'm not done because I'm solving for theta. I have a 3 theta. So now what do we do? So theta equals 0 and 60, 120, and 270, 360, and 450. No, I started dividing by 2, didn't I?
Yeah, no, 3.
What, I divided by 3 the first 3 of them, and then I switched to 2? I was thinking, man, this does not look right at all. Okay, let's try that again. 540 divided by 3 would be 180. 720 divided by 3 is 240, and 300. That looks better. Nice thing about these guys, you can always check if you wanted to take the time to do so. You just have to plug them back in and see if it works. And all 6 of these do work when you put them in. So what would we do here?
Subtract.
Okay, do we have double or triple solutions here or anything like that? Nope, my angle's just a normal theta, so it's just quadrants and reference angles. When is cosine negative? Reference angle, when is cosine radical 2 over 2? So in quadrant 2, 180 minus 45, and in quadrant 3, right, 180 plus 45. Is this helping? Okay. Are you feeling better about it? Huh?
Slightly.
Slightly, that's reassuring.
Oh, yeah. Subtract sine squared divided over plus. That way you get down to
We have all the angles match, so we don't have to worry about that. Since I have sine on both sides, you want to bring it over, so if I subtract that, you get 2 sine of x over 2. So if you want to get sine by itself, we divide by 2. Just remember, guys, can I just like multiply by 2 and get rid of that on my angle? No, you can't touch that yet. So quadrants, when is sine negative? Reference angle, when is sine radical 3 over 2?
60.
Okay. Does this x over 2 tell me I'll have double or triple solutions? No. That happens when it's like a 2x. What that means is between the normal 0 to 2 pi, my graph has 2 complete cycles. This tells me between 0 and 2 pi, my graph only has half a cycle. So sometimes that may not impact it at all. You know, all my answers may work. Sometimes when that happens, I may get answers that fall outside my interval. So we just need to double check at the end. Does that make sense to everybody? Because this graph would really have a period of 4 pi. So if I'm only looking at 0 to 2 pi, I'm only looking at half the graph. It may or may not hit the values that I'm looking for in that section. So we have our angle x over 2 equals, in quadrant 3, 180 plus 60. In quadrant 4, 360 minus 60 is 300. I don't need double solutions, but we do still have to solve for x, so I need to take everything and multiply by 2. So x equals 480 degrees and 600 degrees. Right. There is no solution in the interval. I only asked for the answers between 0 and 360. Now this doesn't mean there's no solution at all. It means it just doesn't happen where I was looking. You know, if you were to graph this, so this was a sine. Okay, this is what the graph of sine of x over 2 looks like. I wanted to know when that hit negative radical 3 over 2, which was here. When I looked at the 0 to 2 pi portion of my graph, I only got the part of my sine that was positive. So just know, like, if this had been a positive radical 3 over 2, both of my answers would have been okay. So it just kind of depends on the problem. Does that make sense to everyone? When do we have to check our answers? If there's a square in the problem to begin with, if we add the square. So if I'm looking at this, first of all, my angles match, so I don't have to worry about that. But I have 2 different trig functions, so that's concerning. We need something to get them to be the same.
Can you just change secant squared into tangent squared plus 1?
Yes. So unlike the problems like the last problem on the homework we did yesterday, we do not have to square this because I already have a secant squared. So that means I don't have to check my answer. I certainly can, but as long as I do my work right, my answer is going to work. It's only if we put the square into the problem that we have to check.
And when's the time when we do put the square in the problem?
If this had just been a secant, then we need it to be a secant squared so we can use the identity, so we would have squared each side. Add over your tangent and then square. Okay. So we have tangent squared theta over 2 minus the tangent of theta over 2. We have a plus 1. If you subtract over the 3, that's a minus 2 equals 0. So tangent squared breaks into tangent. Multiply -2 and add to -1. Okay. So if we set each of these equal to 0, do we know when tangent is equal to 2? No. It doesn't mean it's no solution, it means we're going to use our calculator. Quadrants. Tangent is positive in
20.
reference angle. We are in degrees, so make sure your calculator is in degree mode. And we do tangent inverse of 2. So remember, I know some people yesterday had questions about how to plug this stuff in. If you move the tangent to the other side, that's when you add the inverse. So when you move a trig function, it gains an inverse or loses it. So that would be 63.4349 degrees. So my angle, my theta over 2. In quadrant 1, your reference angle is your angle. What do we do for quadrant 3? Add 180. Okay. Now we solve the other one. Tangent of theta over 2 plus 1 equals 0, so tangent of theta over 2 equals -1. We don't need a calculator, we know this. Tangent is negative 2 and 4. Reference angle, so 45 degrees in quadrant 2, so 180 minus 45 is 135. In quadrant 4, 360 minus 45 is 315. Am I done?
No.
No, I have to solve for theta, so I need to multiply by 2. So I get 126.8698. All of these are solutions. Do I keep them all? Right. My direction said find all the solutions between 0 and 360. So there are only 2 that fit that criteria. The others are not in the interval.
If you got the answer as 360, would you not put it, or would you just put it as 0?
You put it as 0. Other questions?
Would there ever be one like that, but with like a double angle formula thing we have to do or something?
There could. I probably wouldn't do it with tangent and secant. I would do it with sines and cosines if I was going to do a double angle. Okay. So number 14. So looking at this one, all my angles match. They're all just a plane X, so there's no double solutions or anything to worry about. But what do I need to do to start?
You have to get you need 3 cosine x to the other side.
Okay. From here, we need to do what? Box method. Because it is a 2, we need the full box method. So I need two numbers that multiply to 2 and add to -3.
Forgot the square.
Thank you. So when I factor this, we can take out a 2 and a cosine. This way, -1 cosine x minus 1. Now what? So we get, add your 1, so 2 cosine x. So cosine equals 1/2. We know this, quadrants, when is cosine positive? Reference angle, when is cosine 1/2? We are in radians now. So my angle, which is just a plane x, in quadrant 1, pi over 3 is pi over 3. In quadrant 3 would be 4. Oh, no, that's not a 3, that's a 4, isn't it? If I could read my own handwriting, that would help. That's a V. Okay, in quadrant 4, pi over 3 is 5 pi over 3. Alright, this one set it equal to 0. That means cosine equals 1, which only happens once, at 0. If I said all possible solutions, what would you do? Add 2 pi to all of them.
2 pi k.
Yes, 2 pi k. Questions there? Next one. Okay, so this one is concerning for a couple reasons. First of all, I have two different trig functions. But I also look and I have two different angles. So you need to start with the angle issue. We need our angles to match.
Use the double angle.
Yes. There are 3 options to replace cosine 2x. Since my other trig function is a sine, pick the option that involves sine. So that would be
1 minus 2 sine squared x.
alright, so that dealt with both issues. Now everything I have is a sine and everything I have is an x. We need, it's a quadratic, so set it equal to 0. If you're going to do box method, you need your square term to be positive. So let's move everything to the right. So that would be a 2 sine squared x plus sine x, and then we need to subtract our 1. Again, it's not a 1 sine squared. 2 sine squared means we have to do the full box method. So multiply to -2 and add to +1.
2 -1.
we factor, we get a 2 sine x minus 1. This way we get sine x plus 1. So set those equal to 0. So sine is equal to 1/2 or negative. It is just sine x, so we don't have double solutions or anything. Quadrants, if sine is positive, that would be quadrants. Reference angle, when is sine 1/2?
30.
30, we're in radians, so that's pi over 6. So x equals pi over 6 in quadrant 1 is pi over 6. In quadrant 2, that's 5 pi over 6. When sine is equal to a negative 1, that's at 270, which is 3 pi over 2. Any questions? Two more. So where do we start? So 1 sine x plus 1 sine would be a 2 sine of 3x. Remember, when you add those, the coefficients change, not the angles. If I want to get the sine by itself, we divide by 2. Quadrants, when is sine negative? Reference angle, when is sine radical 2 over 2? The 3x tells me what? So in quadrant 3, we would have 5 pi over 4 and 7 pi over 4. So I got 2 answers, so if I want triple the answers, we have to have 2 more for each of those. How do you get the remaining ones? Add 2 pi. Okay. If you use your calculator, don't put in pi. Do pi over 4 plus 2. 2 pi is like 8 pi over 4, so that gives me 13 pi over 4, 21 pi over 4, 15 pi over 4, and 23 pi over 4. But I am not done. I need what x equals. So, all 6 of those have to be divided by 3. So that's the same as multiplying by 1/3. So 5 pi over 4 times 1/3 would be 5 pi over 12. 7 pi over 12. This would give me 15 pi over 12, which reduces to 5 pi over 4. Yeah, this would be 21 pi over 12, so 7 pi over 4. So those are the final answers. notice about this one, first of all? It's a 2x, which means we will have okay. When is sign positive?
1, 2.
Do we know when sign is 1/4? So we use our calculator. We need to be in radian mode. And then to move the sign to the other side, you make it sine inverse of 1/4. So we get 0.2527. Alright. Then in quadrant 1, your reference angle doesn't change. In quadrant 2, you would have to do pi minus that. But double solution, so we need 2 more. How do you get those?
And on these, do we go ahead and just add it completely to the
Yes,
top?
since it's already a decimal, put pi in as well. So you get 6.5359 and 9.1721. Then to finish it, you have to divide each of those by 2. Alright. Questions there?
So the only ones we have to remember are the same ones we've been having to.
You'll get the same formula sheet you had on the last test. Make sure you're reviewing the quadrant piece from section 6.1, knowing which quadrants the inverses are in.
And then do you have like study guides?
Yes, extra handouts box over there. Put several in yesterday. What else? Anything else you want me to talk about?
I feel a lot better now.
You do? Good. So today was not a wasted day. It was helpful, hopefully.